Hello everybody and welcome to a video about notes for lesson 7A part 2 for contemporary mathematics. Alright, so I'm going to write an intro here. Probability measures the likelihood of an event occurring. Talked about that in the last lesson. But expressing the odds of an event happening is another way to show probabilities. For an introduction to this idea, we will look at this statement: the odds against Derby King winning the Kentucky Derby were 5-2. And this is how we would represent 5-2 in mathematical symbols. So what does this mean? What was the probability that Derby King would win the race? Okay. In order to figure that out, we have to look at this 5-2 here, and we have to figure out what do these numbers mean. So we've got 5-2, and these are odds against, and these two words are going to be very important. These two words describe the first number. So what this 5-2 means is that there are 5 outcomes where Derby King would lose the race, and 2 outcomes where Derby King wins. Which means that, of course, if there are 5 where Derby King loses and 2 where Derby King wins, add those up, you get 7 total outcomes. So you can start seeing how this probability may make sense when you're looking at odds. So what does this mean? We've described that. What was the probability Derby King would win the race? Well, it would be 2, the number of favorable outcomes, divided by 7, the number of total outcomes. 2 out of 7, that's the probability. All right, so the probability of an event E occurring is given by this. This is what we were just talking about up here. So the definition for odds against are unfavorable outcomes colon favorable outcomes, and the odds in favor, we just flip them around. Remember, the odds against means that will describe the first number. Odds against, unfavorable; odds in favor, favorable. All right, so Stephen, we'll look at example 1. Stephen rolls a die. Find the probability he rolls a 5. Well, that's not too bad. Rolling a 5, there's only one 5. There are 6 sides to every die. There we go. So now the second one is a little bit different. It's asking you to find the odds against rolling a 5. Well, that's a little misleading. Let's look at C first, because C is going to make a lot more sense with what we just figured out here. Find the odds in favor of rolling a 5. That is, the first number would be how many outcomes would give you a 5 if you roll one die. Well, that's just 1. You have one outcome that is a 5. The other number here would basically ask, how many other numbers could you possibly roll? How many different ways could you get a number that isn't 5? Well, you can get 1, 2, 3, 4, and 6. So those are 5 outcomes that are not 5s. So here is what the odds look like in favor of rolling a 5. Now, once you have one of the odds for a specific event, if you just flip the numbers around that colon, the odds against are exactly the opposite, 5-1. All right, let's see. Next, find the probability of rolling an even number. Well, there are 3 even numbers out of 6 total outcomes. That's 1/2. So find the odds against rolling an even number. So one thing that you will want to think about here is that we have 3 numbers that are not not even. And we also have 3 numbers that are even. And we can treat odds just as though they're fractions. So we can notice that both of these are divisible by 3, giving us a new set of odds, 1 to 1. Because for every odd number, there's an even number on a 6-sided die. All right, next example here. Mario rolls 2 dice. Write out the possible outcomes. So I'm going to pause the video and put them all on here at once so you can see how this is going to work. So here are all the possible outcomes for rolling 2 dice. So the couple things you want to know about this, there are 36 total outcomes. And the first number represents the result on first die. The second number represents the result on the second die. So just for example, this one right here, the first die rolled was a 4 and the second die rolled was a 5. All right, so there are all the possible outcomes. Now, we can start answering questions. What is the probability that the sum of the dice is 7? One other thing, you can take this to the bank, is if you draw some little diagonals here, little diagonal rows along this set of numbers. So something like this. There we go. The sum of each row is going to be the same for each pair of dice. So, for example, if I start here, travel up this diagonal, 1 plus 5, 6. 2 plus 4, 6. 3 plus 3, 6. 2 plus 4, 6. 1 plus... You get the idea. And that works with any diagonal here. 6 plus 4 is 10, 10, 10, when you add each pair together. So, all we have to do is find a row that starts with 7, add those together at 7, 1, 2, 3, 4, 5, 6 outcomes where you can roll a 7. Out of 36 total outcomes leaves you with 1 to 6. 1 out of 6. What are the odds against rolling a 7? Well, there are 6 ways to roll a 7, which means there are 30 ways to roll a not 7. Anything other than a 7. You can pause the video if you want to count up all these other rows as long as it's not this one. And there will be 30 pairs of numbers. If you want to roll a 7, there are 6 possible ways to do that. Now we can take each of these numbers and divide them by 6. When we do that, we get odds of 5 to 1. All right, what are the odds against rolling snake eyes? So here, we want a number of outcomes that are not snake eyes. So everything except for this 1, 1, that is snake eyes. So there are 35 ways to roll something that isn't snake eyes, and there is 1 way to roll something that is snake eyes. So the next thing, or the next question, what is the probability of rolling a snake eyes? Well, there's only 1 way to do it out of 36 possible outcomes. All right, last example here, and then we're done with this actual entire lesson. Thank goodness. The odds in favor of winning a door prize on a certain game show are 5 to 9. So I'm going to rewrite this right away so I know what that looks like. 5 to 9. What are the odds against her winning the door prize? Well, if you know the odds in favor or the odds for, then you can know the odds against just by simply flipping that entire expression around, 9 to 5. So finally, what's the probability of her winning? Well, there are 5 outcomes where she does win. There are 9 outcomes where she doesn't, leading us to understand there are 14 total outcomes. So all we have to do is take the outcomes where she wins and divide it by the total number of outcomes. So 5 over 14. And that concludes the lesson for Contemporary Math, Lesson 7A, Part 2. Good luck.